Now that we know how to determine how many significant figures are in a number, now we're going to actually start doing some calculations with them, okay? And there's one important thing you have to know when you're performing a calculation, whether it's multiplication, division, or addition, subtraction, is that when you're using measured values, so using measured values, your final answer can only be as good as your measured values. Okay, which means that when you're trying to figure out, okay, I get an answer and it's on my calculator screen. How many of those do I put down? You always have to ask yourself, my final answer can only be as good as your measured values. Okay, well, what does that mean? Well, let's come down to the multiplication and division rules. There's two different rules, one for multiplication and division, one for addition and subtraction. They're similar, but they're slightly different. Okay, so again, your answer can only be as good as your measurements. So with multiplication and division, how many numbers do you put in your answer? So the number of significant figures in your final answer is the same as the number with the fewest significant figures. So whichever number has the fewest significant figures in the problem, that's how many go in your answer. Okay? So when you're doing a problem, don't worry about rounding until the very, very end of the problem. You don't round anything until the very end. Okay? And when you round, you have to look at you look at the digit following the last significant figure. For example, if we have this number right here, and we want to round that to 4 significant figures, we go 1, 2, 3, 4. The next number after that 4 is 5 or greater, so that means that this 4 here has to round up to a 5. So our final answer is 24.35. Okay? If we round that same number to 5 significant figures, again, let's count. 1, 2, 3, 4, 5. Notice the next number after the 8 is a 5 or greater, so we have to round that 8 up to a 9. So when you're rounding, it's just that very last digit that you have to worry about. Do I keep it the same or do I round it to the next number? Okay, what if we take this same number here and we round it to just 2 significant figures? Well, again, then we go 1, 2, okay? And the next number after the 4 is less than 5. So that means that we keep that 4 as a 4. We don't round that up to a 5. So if you round that to 2 significant figures, it'd be 24. Okay, the tricky part is how do you round this number here to 1 significant figure? What if you only have 1 significant figure? How do you round the number 24.34859 to just 1 significant figure? Well, it's right here. It's a 2. And then the next number after that is less than 5, so we round that, we keep it as a 4, but it can't be a 4. Okay, it has to be a non-significant figure. Well, what number can we put in there that sometimes isn't significant? Of course, a 0. The number 24.34859 rounded to 1 significant figure is 20. Okay, so rounding can sometimes be a little bit tricky, so let's look at some examples here. Well, let me show you one. Okay, let's look at the number 100. Okay, from what we learned in our previous lesson, the number 100 written like that has 1 significant figure. The number 100 with a decimal point at the end has 3 significant figures. Okay, you can also write 100 with 2 significant figures. And the only way you can do that is to put it into scientific notation. You can go 1.0 times 10 to the second. And see how that has 2 significant figures? That is the only way you can write the number 100 with 2 significant figures. So here it has 1, here it has 3, and here it has 2. Okay, let's look at some examples here. So we're going to take the number 4.56, we're going to multiply by 1.4. You multiply those together, the calculator answer is 6.384. But because 1.4 only has 2 significant figures, your answer can only have 2 significant figures. So we go 1, 2. The next number after that 3 is 5 or greater. It's an 8. So we have to round that 3 up to a 4. So our final answer is 6.4. Okay, and then we take 0.00105 and we divide by 6.135. get our calculator answer of 0.0001711149. Okay, and again, now we come back. And guys, this is actually going to help you because now you never have to wonder, hey, how many digits, how many numbers do you want me to put in our answers? Okay, significant figures tell you how many digits to put in your answers. Okay, so this has 3 significant figures. This has 4. So since 3 is less than 4, our answer can only have 3. So we count 1, 2, 3. The next number after that 1 is also a 1. So therefore, we don't have to round that 1. So our final answer is just that 0.000171. Remember these zeros right here. These are leading zeros. Those are not significant. Okay, so why don't you try these out? There's 3 examples here. Go ahead and try them out and solve for the unknown variable that it tells you for. This is a little bit of algebra review here as well. And then again, the key here is make sure that your final answer has the correct number of significant figures. Okay, so for part A, we've got to put those numbers into the equation. So R is going to equal 2.560. And these are actual chemistry equations that we're going to learn about, either in general chemistry or some of them we learn about in AP chemistry. This first one is one that we will learn about this year. So I'm just plugging the numbers into the equation here. Okay, and now I'm going to go to my calculator. I'm going to type in, listen to how I do this if you don't get the same answer as me. 2.560 times 8.8 divided by 0.125 divided by 275.15. Okay, calculator answer is 0.655002726. Okay, and so now we need to check and see our significant figures. This has 4. This has 5, this has 3, but this answer here, or this number here only has 2. So if one of your numbers only has 2, then your answer also can only have 2. So therefore our answer is 0.6. And remember it was 0.655, so the next number after this 5 here was 5 or greater, so that means that 5 has to be rounded up to a 6. So your final answer should be reported as 0.66. Okay, so to find V1, we have to do a little bit of algebra here. To find V1, we have to divide by M1. That's algebra. So we're going to take M2 times V2. So that's 0.500. That's M2. V2 is 125.0. And M1 is 6.25. So I'm going to take 0.5 times 125 divided by 6.25. And the answer comes out to be exactly 10. Okay, so if the answer is exactly 10, now again, I need to look for 3 significant figures, 3 significant figures. I need to have 3 significant figures in my answer. So if my answer is 10, if I leave it like that, that only has 1. If I put a decimal point at the end, now it has 2. I need it to have 3 though. Okay, and 10.0 is your way to have that have 3 significant figures. Because remember, that's a final 0 after the decimal point, so it counts. Remember, the only time zeros don't count are these zeros right here. Those don't count. And like these zeros right here with no decimal point. That's the only time zeros don't count. Okay, so in that case, yes, that 0 counts. Okay, and then our final one, to find C, we've got to get C by itself. So C, we're going to divide by M and T on both sides. So C is going to equal Q over MT. So Q equals 0.156. M is 120, and T is 275. Notice that M, well, we'll get to that in a second. So we're going to take 0.156 divided by 120. And then again, divided by 275 equals a whole bunch of zeros. 0.00000. So I'm actually going to put that into scientific notation. So first of all, 3 significant figures, 3. This one only has 2. So my answer can only have 2. So that is going to be 4.7. And again, you don't have to put it in scientific notation, but you certainly can. Okay, times 10 to the minus 6. So there's my 2 significant figures. I got rid of all those zeros at the beginning. Of course, if you also put 0.000047, that would also obviously be okay. Okay, in our next video, we'll talk about how to do that with addition and subtraction.